In this video, we're going to talk about permutations. But before we get to that, let's take a look at a couple of quick examples. So let's go back to the TMNT example. Suppose you want to rank your 2 favorite turtles instead of ranking all 4 of them. How many ways can I arrange them? So remember, it's Leonardo, Raphael, Michelangelo, and Donatello. Only ranking the top 2. So there's 4 to pick from the beginning. We're not going to pick the same turtle again. So there's only 3 to pick from. And there's 12 different ways that I can arrange 2 turtles out of 4, where order matters. All right, so suppose you have 7 different colored shirts, and you want to select 5 of them to wear next week in your order of preference. How many different shirt arrangements do you have? Well, 7 to choose from to start. Again, not going to wear the same shirt again in the same week, so that's 6, then 5, then 4, then 3. Multiply those together, that's 2,520. These 2 previous examples are examples of permutations. A permutation is an ordered arrangement of a given set of objects. We are arranging distinct items where order matters with no repetitions. The number of permutations possible of selecting n items taken R at a time is given by the formula below. So, let's take a look at a couple of examples. So we want to do the permutation of 4 things taken 2 at a time. Well, according to our definition, the 4 is the n, the 2 is the r, so it is going to be n factorial over n minus r factorial. N is 4. 4 minus 2, that is 2 factorial. So expanding out 4 factorial, that's 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Divide out the 2 and divide out the 1. That leaves me with 12. So the very first example of the TMNT example, that is also a permutation of 4 turtles, and I'm selecting 2 of them. Okay, a permutation of 7 things taken 5 at a time. So when I write, the 7 is the n, the 5 is the r. So writing this out, that's 7 factorial. 7 minus 5, that's 2 factorial. So I'm going to set this up a little different. I'm going to go 7 times 6 times 4 times 3, and I'm going to stop at 2 factorial because that's exactly what I have in the denominator. Remember, I could write it as 2 times 1, but I'll stop there. So 7 times 6 times 4 times 3 is 2,520. The shirt example that we just did was also a permutation of 7 shirts, and I'm selecting 5 of them for the week. Okay, a permutation of 5 things taken 0 at a time. Again, writing it out, n and r, the formula. That's 5 factorial. 5 minus 0, that's 5 factorial. So 5 factorial divided by 5 factorial, that is 1. So when I have a permutation of n things taken 0 at a time, that's 1. All right, so a permutation of 8 things taken 8 at a time. So again, writing this out, that's n and r. Writing it, that's 8 factorial. 8 minus 8, that's 0 factorial. Remember, 0 factorial is 1, not 0. Okay. The 1s, of course, are going to divide out. This is really the same thing as 8 factorial, isn't it? Because it's really 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 40,320. So when I have a permutation of n things taken n at a time, that's equal to n factorial. Now, these formulas you don't need to know as long as you understand how to use the permutation formula, but those are exceptions to this rule here. Okay, let's take a look at the next example. Suppose 10 countries are competing in the World Basketball Championship and the top 3 countries get a medal. First gets gold, silver for second, bronze for third. Assuming a country can only get 1 medal, how many ways can 3 medals be distributed? So again, we're talking about n items taken R at a time, where order matters, and I can only select each individual item, or in this case, country, once. So this is a permutation of 10 total countries, and I'm going to select 3 of them. Remember the formula. That's n factorial divided by n minus r factorial. Here's n, here's r. So it's 10 factorial. 10 minus 3, that is 7 factorial. So remember how I'm going to write this out. 10 times 9 times 8 times 7 factorial, because that's what I have on the bottom. The 7 factorials divide out. So 10 times 9 times 8, there's 720 arrangements I have in this problem. Okay, let's take a look at the next example. 12 students are competing for 2 different writing scholarships. How many different ways can the scholarships be rewarded? So again, n items taken r at a time. The order matters because they're different scholarships, and I'm only going to select each individual student once. This is a permutation of 12 students taken 2 at a time. So again, here's your n and r. So n factorial, that's 12 factorial. 12 minus 2, that's 10, so that's 10 factorial. So I'll write out as 12 times 11 times 10 factorial. And this helps, I don't have to write all those extra numbers out. 12 times 11, that's 132. There's 132 different ways I can reward the 2 writing scholarships. So up to this point, we've dealt with permutations of distinct objects. What happens if there are duplicate items, but the order still matters? This is where the permutation of duplicate objects come into play. So this formula is n factorial divided by n1 factorial times n2 factorial times n little r factorial, where n is the number of objects, n1 is the objects of identical, n2 are the number of objects that are identical. So let's take a look at a couple of examples. Suppose you're playing Scrabble and the letters that you have are 3 E's, 2 R's, a T, and an S. How many different arrangements do I have with the letters for my tile? So again, order matters for this, and I can only use each individual letter once, but there are going to be repetitions. So there are 3 E's, there are 2 R's, there is 1 T, and there's 1 S. So on the top, there's a total of 7 letters divided by, well, there are 3 E's, so on the bottom, that's 3 factorial. I have 2 R's, so on the bottom, that's going to be 2 factorial. 1 T, I'll write it as 1 factorial. And 1 S, that's 1 factorial. Okay, so let's write this out. That's 7 times 6 times 5 times 4. I'm going to stop at 3 factorial because I have a 3 factorial on the bottom. 2 factorial is 2 times 1. 1 factorial is 1. And 1 factorial is 1. The 3 factorials divide out. The other thing I can do, 2 goes into 4 twice. So I have 7 times 6 times 5 times 2. And that gets me to 420 possibilities of rearranging all those letters. Okay, one other example. Let's take a look at Mississippi. Again, we want to arrange the letters, the order matters, and there's definitely repetitions. So what do we have? We have 4 S's, we have 4 I's, we have 2 P's, and we have 1 M. So how do we set it up? There's 11 letters in Mississippi, so it's 11 factorial. 4 S's, that's 4 factorial on the bottom. 4 I's, 4 factorial. 2 P's, so that's 2 factorial. And then 1 M, that's 1 factorial. So I can write this out. I'll stop again at 4 factorial. Now one of the 4 factorials I'll write out. That's 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 1 factorial is 1. The 4 factorial, they divide out. So at this particular stage then, I can start dividing out common factors. The 4 times 2, which is 8, I can divide out the 8. The 3 times 2, which is 6, that goes away. So at this stage, I have 11 times 10 times 9 times 7 times 5 to put into the calculator. That's 34,650.